Hello all, welcome back to Data Science Brain. In this video, we will see Llama 3, that is Meta's newly launched LLM, which is the most powerful, capable, open source LLM till date. And we will also see how we can run it in Python in Google Colab and get the results. And we will also see how you can use it on the go on Groq.com and use it like ChatGPT. So let's get started. So Llama 3 by Meta is the most powerful, openly available large language model till date. It has been introduced by Meta a couple of days ago, and it is being the third version of its family, Llama. So Llama 3 comes in two variants currently: the 8 billion parameter variant and 70 billion parameters variant. Obviously, those terms means that one is the 70 billion parameter is more powerful than the 8 billion parameters. Okay, so it can be used according to the use case, and it has already been demonstrating state of the art performances over wide range of industry benchmarks, which we can see below. And it has been able to compete with some of the currently existing popular models like Cloud, Gemini, and ChatGPT. And also it is the currently the best existing model in the scale of 8 billion to 70 billion parameters. Okay, so basically a large language model is a kind of an artificial intelligence model that is made to understand human like text and generate human like text. Okay, so basically ChatGPT, I hope everyone watching this video has already been using ChatGPT. So this is basically just like ChatGPT. Okay, this is basically ChatGPT. Okay, and it is available open source, created by Meta. So as you can see, some of the benchmark performances here, it has been able to actually overthrow Gemini, Cloud 3, and Mistral in both the 7-bit, both its 8 billion and 70 billion parameter types models. Okay, so as you can see, there is a clear difference between this model and the other Gemini and Cloud, Gemini, Cloud, Gemma, Mistral, all these models. As you can see, Meta's Llama 3 has been able to overthrow all those models in terms of benchmark performances. Okay, also you can see they have done a human evaluation, across different things, comparing models like ChatGPT 3, Mistral, Cloud, and Meta's on Llama 3. And Llama 3 has been able to defeat ChatGPT 3.5 and Mistral and also Cloud by a really good margin. Okay, as you can see, it has been able to defeat ChatGPT 3.5 in human evaluation with around 63.2 percentage. Okay, so um, that's a really good output, considering the fact that it is open source and it is available to, you can check the code in their GitHub repository. I will be leaving the link to that in the description. So that is really good. Okay, and as you can see, this is again the same similar kind of benchmark comparison that we have seen above, and it has been able to defeat Gemini, Gemma, Mistral, and Mixtral as well. Okay, in the 8 billion and 70 billion parameter scaled models. Okay, and also compared to Llama 2, they have used a tokenizer with a vocabulary of 128,000 tokens. Okay, so which will be able to encode languages much more efficiently, and this has improved the performance of the model much better. Okay, so it uses a tokenizer that is much larger than the tokenizer with vocabulary much larger than that in the Llama 2 version. Okay, and Llama 3 has been pre-trained with over 15 trillion tokens. Okay, so 15 trillion tokens have been used for training Llama 3. The tokens are basically words, okay, like English words, English or other language words that has been used to train Llama 3. Okay, so 15 trillion, that's a huge number that were collected from publicly available sources. Okay, and also they have used almost 5% of this 15 trillion tokens. They have used some of the words from other different languages, like 30 different languages. Okay, non-English languages, for they are preparing it for multilingual use cases. Okay, so as you can see, our 5% of Llama 3 pre-training dataset consists of high quality non-English data. Okay, so that is good. And also, as for the future of Llama 3, they are planning to release a 400 billion parameter model, which will be much, much more powerful and probably will be competing or even overthrowing that of models like ChatGPT 4 or maybe Gemini's Pro versions or anything like that. Okay. So this will be able to overthrow them as well. So that's all about llama 3, and I will be leaving the link to this blog in the description. Now let us see how we can code and use this llama 3 to get a response by asking it some questions. How we can use it in Python. Okay, let us see the Python code for using this. Okay, so let's now see how we can use llama 3 in Python for text generation. Okay, so we need to do a couple of installations first. I will be using Google Colab. Okay, I won't be using my local IDE. I will be using Google Colab for this because it has already built in a lot of GPUs and RAM as well ready to use. So I'll be going to utilize that. Okay, so before we do this, most people will encounter an issue if you run this code without doing this. So you have to switch your runtime, change your runtime type to T4 GPU. Okay, so you have to pick up T4 GPU hardware accelerator from the list. Most of you will be already be having CPU selected here, so you have to switch to T4 GPU before continuing. Okay, so otherwise this won't work. Otherwise this won't run. Okay, so you need GPU to run this large language model. Okay, so you need to do a couple of installations. First, transformers from Hugging Face, and also the other two libraries, accelerate and bits and bytes. So the accelerator library is used for accelerating the training and the evaluations and all. And the bits and bytes library is like it's like a wrapper around the CUDA functions, basically used for some matrix multiplications and all. So you need to install it if you haven't already installed it. I have already installed it in the Google Colab, so it won't take much time. For you, it might take a little bit more time. Okay. So after that, let us start by importing. Okay, we will first import the transformers from transformers from, okay, spelling mistake. And also we will import torch. So we'll be using PyTorch. So we will import both of that. And after that, let us create a variable to store the model ID. So in Hugging Face transformers, there are several models used now. So each model has its own ID. So we need to pass in that ID to the pipeline to mention that we need to use the particular model. So for Llama 3, this is the model ID. Okay. So let us now create a pipeline. We'll say pipeline. So these are just basic machine learning tasks. Okay, that you need to do pipeline creation and all. So we'll say transformers dot pipeline. So we are saying the kind of task that we need to do is text generation. The task name is just text generation, and the model that we need to use for text generation is llama 3, this model, by passing in this model ID. And we also give some keyword arguments. Okay, we'll say keyword arguments. So we are using these keyword arguments to tell the machine that we need, tell the model that we need to use as much less memory as possible. Okay, we will say the torch data type is equal to torch d type is equal to, we will put it as torch dot float 16. So this is to reduce the memory usage. Okay, and also we will say low CPU mem usage, we will set that to true. Okay, so these two keyword arguments will allow us to use, allow the model to use less memory as possible. Okay, so setting the torch data type to float 16 means that the binary floating point format that is used to represent the tensors is in 16-bit. Okay, so it is only half precision. So usually it is stored in a state 32-bit floating point numbers, but here we are mentioning that we only need 16-bit. Okay, but the precision will be low, but the memory usage will be less. Okay, so let us run it. It will take some time. Okay, we got an error. Module transformers has no. Okay, of course it is pipeline. Okay, not pipeline, it's pipeline. Okay, now it will run. It will take some time to run, depending on your, obviously depending on the memory, the RAM and the GPU RAM that is used by your Google Colab. So after we have finished running that, running the pipeline, we will set the messages, and also we will pass in that to the pipeline to get the result. Okay, so let us first set the messages. So we'll send in two messages. We will assume two roles. We will assume first the role of a system, and we will say, okay, we will say system role is equal to system, and we will say the content. So this is like we are assuming the role of a system and we are speaking to llama 3. Okay, so we are telling it that you are a teacher. Okay, so this will be the first command. We are telling as a system to llama 3 that you are a teacher, and next we will assume the role of a user. Okay, or let's say, okay, yeah, user, I mean, sorry, role user, and the content will be explain LLMs to me as if I am new to this field. Okay, so we are basically making llama 3 a teacher and we are telling it to explain us about LLMs as if I am new to this field. Okay, so we will make the prompt using this message. So we will say, we will use our pipeline. So we will say pipeline dot tokenizer, apply chat template. So a tokenizer is basically something that is used to convert this text data into tokens, basically, represented in a way that machines can understand, and which is in a numerical way. Okay, also this apply chat template, which is function of this tokenizer, is specifically used in this kind of use cases where it's a chat based interaction. Okay, so this will help us formatting the message that is suitable for chat based interactions. Okay, so into that we will pass in first the messages. So we'll pass in the messages, and we will say you don't have to tokenize this message because it will be pre-tokenized or something like that, and we'll say add generation prompt is equal to true. Okay, so this is important because this will allow this tokenizer to add a particular token that will tell the model that this is for like text generation. Okay, this will tell the model that this is for text generation. You need to generate the text as a reply to this particular message. So this is used to set that kind of token. Okay, so this is important if you need a reply from the LLM model. Okay, so this will basically make our model a similar to ChatGPT. Okay, so that's why we need to set this to true. Okay, now we will define some terminators to let the model know when to stop generating the text. So this is just basic tasks that we do when we are training uh, LLMs like this. So we'll set terminators is equal to, we'll set two terminators that we get from the pipeline, the Hugging Face pipeline, transformers pipeline. So we'll set tokenizer dot EOS end of sentence token ID. So when the model sees this token, it will stop generating. And also one more thing, pipeline dot tokenizer dot convert tokens to IDs, and we will pass in a special kind of character that is used in Hugging Face token transformers, specifically for text generation. This is used for representing the end of generation of the text. Okay, so we are converting that to ID. So whenever the model finds these two things, it will stop generating the text. Okay, that's all that this is. Okay, now we will get the outputs. So we'll say outputs is equal to, we will say pipeline. To the pipeline we will pass in the prompt, and we'll say max new tokens is equal to 1024. So this is just mentioning that mentioning the number of words that we need in return. Okay, so this will set the maximum limit of words to generate. Okay, also we will set the EOS token ID to the terminators. So whenever the model sees these, it will stop generating. Okay, So we'll also say do sample is equal to true. Okay, so this do sample is equal to true is important because it will allow the text generation process to be sampled. Okay, so whenever it select the next token during the generation, it will introduce some randomness into the process, okay, which can lead to more diverse and interesting outputs compared to the compared to a deterministic or perfect approach. Okay, so that's why that is there. And also there are two more things that will allow to introduce to set the randomness, that is temperature is equal to 0.6. So this will introduce a moderate randomness. Okay, temperature is equal to 0.6. Also another parameter is there, top p is equal to 0.9. So this is related to top p sampling, a technique that is used in text generation. So this will control the diversity of the generated text by restricting the probability distribution of tokens considered during sampling. Okay, so you don't need to worry much about all these things. This is just to introduce some randomness in the generated text. Okay, so that's all what this is about. Okay, so now that we have set up the pipeline perfectly, we will print out the outputs. uh, we will say outputs, and from the output we will take generated text, and so we need all the generated text. So we will say length of the prompt until the end. Okay, so we will print all the complete output. Okay, so let us run it. It will take some time to run. So after it has finished running, and we can see the result here. So it has generated the result of our question of explaining LLM to someone new to this field. So we will just copy and paste it to a text field, and we will get the formatted output. Okay, so it has said that welcome to the fascinating world of LLMs. As I'm a teacher, I'm excited to introduce you to this cutting edge technology. And so it has basically explained LLMs to us as if we are new to this field. Okay, so you can read through it if you want. So great, so we were able to run LLM LLM model llama 3 using the Hugging Face transformers library, and in Python using Google Colab. So make sure to check this out. I will be leaving the link to this code in the description. You can check it out, you can play with it, and you can try it out to run it in your own system if you have good enough VRAMs. I mean, believe it requires something around more than 16 GB something VRAM in your GPU. So that's about how to run it on Python. Now let us see how we can use this Llama 3 for free easily, just like ChatGPT. Okay, how we can chat with it without even running any code. Okay, so for using Llama 3, all you have to do is go to Groq.com, Groq HTTPS, Groq.com, and then you have to log into it. I have already logged in, and after that, you can just select Llama 3 from the listed models. There are other models as well. So we are selecting the 8 billion parameter Llama 3 model, or let us select the 70 billion parameter, and we can ask questions here just like we ask ChatGPT. Let's say, what is LLM? Explain it like a pro. Okay. So just like ChatGPT, we can ask it questions, and it will answer it perfectly. Okay, so that's how we can, and you can see it is much way more faster than ChatGPT, isn't it? It has answered us way more faster than ChatGPT. Okay, so it is really efficient. You can use this just like ChatGPT and much more faster. uh, it is ready to answer your questions. Okay, so that's it. That's all about this video of introducing you to Llama 3, the new LLM, the fastest, most powerful LLM model by Meta. And I hope you have understood what Llama 3 is, and also you were able to get this code, and you can run this code in your Google Colab or in your system, and you can try out new things by adjusting the parameters and all. And also, if you want, you can use this Groq.com to chat with Llama 3, just like in ChatGPT. Okay. So I hope you have enjoyed this video. If you found it useful, then kindly like and subscribe to our YouTube channel if you haven't already, and also share this video with your friends. Okay, and comment down your views and comment down your request for new videos Also watch our computer vision video that we have posted lastly. I mean, making you control the brightness and volume using hand gestures. Okay, so try to watch that video as well. And thank you. I will see you in the next video. Okay.